Okay, I'm going to work out the quarterly assessment practice test. Okay, the first problem, we're going to have, let's get red. We're going to have, we're going to do the parentheses first. So we're going to have 2 minus 5 minus 8 is a negative 3. 4 minus 6 is a negative 2. Now I need to do the multiplication next, not the subtraction. So negative 3 times a negative 2, that's going to be 2 minus, that would be a positive 6. And so 2 minus 6, we would have that equal to a negative 4. Next one, we have, we're going to have to work on the denominator. So the numerator is going to be a negative 15 plus 7. That's going to be a negative 8. The denominator will be a negative 2 minus 1 because we have two subtractions, so we'll work from left to right. So a negative 2 minus 1, that's going to be a negative 3. And then I'll have minus this negative 5. So that's going to be a negative 8. And so I'll have a negative 3 minus a negative 5. That's going to be a negative 3 plus 5. A negative 8 all over 2. So I'm going to have a negative 4. Next problem is evaluate using the values given. So what I need to do is fill m in for this, and there's a q here, so let's not forget about it. So I have a negative 5 times 7 squared, that's 49, all over 5, plus q. Okay, so there's nothing added. This is all multiplication. What this 5 can actually cancel into this negative 5. That would give me a negative 1 times 49 plus 10. So I need to do the multiplication first. That's a negative 39 plus 10. Negative 49 plus 10. I'm already thinking of the answer. That'd be a negative 39. Notice that because all there is multiplication in the numerator, I was allowed to cancel. If there was an addition or something up there, I can't. Let's move to the next one. We have z is equal to a negative 1 plus 6, and the y is 3, minus x. X is a negative 9, and y is 3. Okay, let's do our multiplications. Negative 1 plus, wait a second, I got something stuck in there. Okay, that's better. So now I've got it written right. So I got a negative 1 plus 18 minus a negative 9 times a negative times 3, a negative 27. Okay, I got a negative 1 plus 18, that would be 17 minus a negative 27. 17 plus 27, that would be equal to 44. Okay, simplify. I'm going to have a minus 5p. Now, plus, let's take the 5 and multiply it by the 4. That would be 20p. 5 times the 3 would be plus 15. My like terms will combine, so a negative 5p plus 20p, that's 15p plus 15. On the next one, I'm going to have a negative 4 times 5n, that's a negative 20n. A negative 4 will also multiply by 1, that would be a negative 4n. Oops, this negative 4n times 5n, the n's multiply, that's squared. Minus 4n. Now then over here we have a negative 3 times 8, that's a negative 24n. And a negative 3 times 7 would be minus 21. Let's combine like terms. There's only one squared term, so that's a negative 20n squared. I have a negative 4n minus 24n, that's minus 28n, minus 21. Okay, that would be D. Solve each equation. Alright, so what we need to do is we need to get the x alone. So the first thing I'm going to do, I'll just rewrite it. A negative 7 is equal to 2x plus 6 minus 3, so that's going to be plus 3. So I'm going to subtract 3 from both sides. So if I subtract 3 from this side, subtract 3 from that side, I get a negative 10 is equal to 2x. Now I'm going to divide both sides by 2, so that would be negative 5 is equal to x. The next one, negative 29 minus 6v is equal to a negative 7. Let's distribute the 7 in. That would be plus 14v. 7 times a minus 6 is a negative 42. Alright, let's combine terms. So I'll have a negative 29 minus 6v, and I have a negative 7 minus 42. So that's going to be 14v minus 49. Okay, let's add 6v to both sides. So I will have a negative 29 is equal to 20v minus 49. Now I'm going to add 49 to both sides. So I would have 20 is equal to 20v. 1 is equal to v. Okay, an absolute value, remember what we need to do is we need to set up two equations. One is going to be 3 minus 7x is equal to 11. The next one will be a negative of what's ever in there. 3 minus 7x is equal to 11. For this side, I'm going to subtract 3. I have a negative 7x is equal to 11. No, sorry, 8. And divide by the negative 7, I get x is equal to a negative 8/7. On the other side, I'm going to get rid of the negative by dividing both sides by negative 1. That gives me 3 minus 7x is equal to a negative 11. Now I'm going to subtract 3 from both sides. I get a negative 7x is equal to a negative 14. So dividing both sides by negative 7, I would get x is equal to 2. So I have a negative 8/7 and 2. Next problem. I have set up my two equations. 5m plus 7 is equal to 27. And a negative of 5m plus 7 is equal to 27. So I'm going to subtract 7 from both sides. I got 5m is equal to 20. Divide both sides by 5, I get m is equal to 4. Over here, let's distribute this one in this time. 5m minus 7 is equal to 27. Now I'm going to add 7 to both sides, so I've got a negative 5m is equal to 34. And now if I divide by 5, I got m is equal to a negative 34 all over 5. So let's see which one matches. 4, A. Solve the inequality and graph its solution. Okay, it's an absolute value. So I'm going to set up two equations. The first one is going to be, and this is a greater than sign. So first, the absolute value is isolated. There's nothing added or subtracted, so that's okay. So I'm going to, this will be an or, because it's greater than. So my first equation is 10, oops, we don't need the absolute values. The absolute values has to go away. So I have 10 plus 4a is greater than 46, and or a negative of 10 plus 4a is greater than 46. Okay, simplifying over here, I'm going to subtract 10. 4a is greater than 36. Here I'm going to divide both sides by a negative 1. That would give me 10 plus 49, and when I divide by a negative 1, that means the inequality sign will change. That's a 4a, that's a. So that'd be a negative 46. Over here, I would have a is greater than 9, or first thing I'm going to do is subtract a 10 from both sides. That would give me 4a is less than a negative 56. This a is still greater than 9. Or when I divide by 4, I'm going to get a is less than a negative 14. So we're looking for, there's no, be open dots, both of them, and a is greater than 9. Let's see if we can see that. Here's one where a is greater than 9. So this is actually the only one that's got that. So I think it must be this one. So a is greater than 9. Also, this side shows a is less than 14. C. Okay, splitting this up into two equations. Again, I have, this will be an or because it's a greater than. I have 6 minus 10r is greater than 16, or a negative of 6 minus 10r is greater than 16. Working on the left side, I'm going to subtract 6 from both sides. So subtract 6, I get a negative 10r is greater than 10. Let's go ahead and work that out, dividing both sides by a negative 10. Now remember, when I divide by a negative, I'm going to have to switch the sign. So I have r is less than a negative 1. Okay, on the other side, let's go ahead and just distribute this one to do it a different way. A negative 6 plus 10r is greater than 16. Now I'm going to add 6 to both sides. So I have 10r is greater than 22. And now I'm going to divide by 10. So I get r is greater than 22 all over 10, which that would be, if I put it to a mixed number, that would be 2 and 2/10, 2 and 1/5. So once again, there are no equal to signs, so anything with a closed dot will not work. And it's an or, so I'm looking for something where r is less than a negative 1. That looks like it could be it. And r is greater than 2 and 1/5. Sure enough, that matches there, so it's A. Find the slope of the line. Okay, so we're going to take the difference of the y's, 14 minus 12, over the difference of the x's, which is a negative 8 minus 3. That'd be 2 all over a negative 11, or a negative 2/11. Over here, I would have a negative 1 minus a negative 8 all over 2 minus 7. That would be a negative 1 plus 8 all over a negative 5. That would be a 7 all over 5 negative, a negative 7/5. Find the slope of each line. Okay, this will be a negative slope. I'm going down 1, 2, 3, 4, 5, 6. So I'm going down 6, and I'm going over 1, 2, 3, 4. Negative 3 halves. Three more problems? Nope. I can't see all those, so I'm going to have to... Still not right. Okay, so first thing is we notice that we have a negative on the... It's an absolute value. We have a negative on the absolute value, so it's going to be reflected over the x-axis. This cannot be the right answer. We also see that h is 4, k is a negative 1. So it should move 4 to the right and down 1. So 4 to the right, down 1, that's A. Next one is it's a squared, so those all look right, and it's going to be, say, that h is a negative 2, k is 3. So it's going to go 2 left, up 3. 2 left, up 3. It's kind of hard to see. This one goes 2 left, down 3. This one goes 2 left, up 1, 2, 3. It looks like C. Okay, this is a square root graph. H is a negative 2. K is a negative 5. So I'm going to go 2 left, down 5. 2 left. Well, they can't be this one. Can't be this one. Can't be this one. So I assume they're so small, they're hard to see. It does look like it's 2 left, down 5. I'm going to pick that one. All right, find the slope-intercept form of the equation of the line to the given points with the given slope. Okay, so it's through these 2 points with a slope of a negative 2. Now, most of you like the slope-intercept form, so I'm just going to use it. Wait, I'm going to jump over while I have the thing shrunk and do these 2 graphs. It looks like that's the end of it. So sketch the graph of each line. This is going to have a b of a negative 5, so it's going to be crossing at a negative 5 on the y-axis. And it's going to have a slope of a negative 2. Okay, so let me see if I can figure out which one of these has a b of a negative 5 on. So it's going to go downward, that's for sure. So we can count this one out and this one out. And so which one of these crossing a negative 5? I think this is crossing at a negative 3 from the best I can see. So I'm going to pick that one. So I'm going to put this in, well, actually, I'm going to do this one with the intercepts. Okay, so if I cover up the x or the y value, I'm going to get x is equal to 3/4. That's going to be my x-intercept. So 3/4 is 0. And if I cover up the x value, I'm going to get y is equal to negative 3. So I'm looking at a graph that has those intercepts. So this one here looks like it's crossing at 1 on the y. That's not going to work. This one is crossing at a negative 3. That could work. This one is crossing at a positive 3. That will not work for the y. Looking at the last 2, then we have one that says, don't forget, it's got to be crossing at 3/4 for the x. This one crosses at a negative 3 for y, but doesn't cross at the right x place. This one crosses at a negative 3 and 3/4, so this one is correct. All right, let's go ahead and increase the size of the screen. Okay, I just now noticed that I missed this problem that is numbered 4, so I'm going to do that next before I go down and finish the last few problems. This one is asking to identify the graph that matches this equation. And the first thing I want to say is when we look, see it's got some shifts going on. It also has a stretch of 2. So what we really want to do is we're going to look for the point 0, 0 because it's not going to be affected by the stretch. I mean, think about it. The way I showed you how to graph these things was you would take, like this would be 2y plus 4 to see where the y moves. And you can see that the point 0, 0, this would be 2 times y. Well, it's just going to be the shift of 4. So 0, 0 will not be affected by this stretch. So that's the point I'm going to look at. And what you can think of is that when we have, this is going to be a cube root, that the 0, 0 point is right there at that inflection. So I'm going to see where that moves, and that would identify the shift. So as we go through these, we can see that the h value is 1 and k is 4. So I'm looking for something that would move 1 to the right and 4 up from this inflection point. So we can see over here, number B, that looks like it goes left, 1 left. No, can't be that one. Looking at C, well, that goes 1 to the right, but it goes downward, so that's not it. You can see that the 0, 0 point has gone down to -4 right there, so it can't be that one. This one here looks like a square root, not a cube root, so we'll get rid of that. We only have one option left, and you can see that, yeah, this point, which would be 0, 0, has moved from 0, 0 over 1 up 4, so it has to be A. Okay, so let's go finish these up. The ones that we have left, I think, are writing the equations of lines. So here's one. It says, find the equation of a line through a -3, -3 with a slope of a -2. Well, if it's going to have a slope of a -2, then you remember the equation is y equals mx plus b. The slope is this. It has to have the m equal to a -2, so maybe I can narrow it down. So A has a slope of a -9, B has a slope of a -1, C has a slope of 2, so I know that it's going to be D. But let's go ahead and work this one through anyway, because maybe your test is going to have something that may be not quite so easy to identify. And what I'm going to do is I'm going to use slope-intercept form to identify what this equation is going to be. So I just said that I know what the -2 is. I'm going to need to find B, because I don't know what the intercept is. So let's go ahead and plug the point that we know in for the y and the x, and we should be able to find B. So plugging the -3 in for y, so a -3 is equal to, I know the slope is a -2. It passes through this x-coordinate of a -3 plus b. -3 is equal to 6 plus b, subtracting 6 from both sides. So if I should subtract 6, I would get this. I would get b is a -9. So now I have enough to write my equation. Y is equal to the slope, a -2 times x, minus 9. And sure enough, that's also what D has, so I just wanted to run through the procedure in case you had a problem where you couldn't just identify it so easily from the slope. All right, let's do the next one. And it says write the slope-intercept form of the equation of a line through the given point. So I need to find the slope of this line. It doesn't give it to me like the one up there. So here's the slope, 1 minus a -5, a -2 minus 3, 1 plus 5 all over a -5, -6/5. So I'm looking for something that has a -6/5. Well, we can already see there's only one of those. That would be B. Let's go ahead and carry this out like I did above. So we know the slope. Now we need to find the y-intercept if we use this form. y is equal to mx plus b. We know the slope is a negative 6/5. We know that it passes through one of these points, so I can pick any one I want to use. This one looks like it's smaller numbers, so 1 is equal to a negative 6/5 times a negative 2, because that's the x-coordinate, plus b. 1 is equal to a negative 6 times, that'd be 12/5, plus b. Subtracting 12/5 from both sides, 1 minus 12/5 is equal to b. Making the 1 a common denominator, 5 over 5 minus 12/5 is equal to b. So I would have a negative 7/5 is equal to b. Now I can plug that into the equation. Y is equal to the slope times x plus b. And that also matches b. Now I use slope-intercept form to calculate that out. Remember, we had another equation form we could use. Y minus y1 is equal to the slope times x minus x1, where y1, x1, that would be a point that it passes through. So what I already found the slope, so that could go in here for minus 6/5. X minus x1 would be x minus a minus 2, right? There's a point. And y minus 1. And if you work that out and convert it into slope-intercept form, you would get the same answer. Okay, so I'm going to do the next two, and I'm not going to go work through them all if I can find an answer real easily. So find the slope-intercept form and equation of the line described through 2, -3, parallel to this line. If it's parallel to this line, it has to have the same slope. This line right here has a slope, and I'm going to say m prime of 1. So my line also has to have a slope of 1. So which one of these lines has a slope of 1? Well, this one and this one are not. So we are going to have to work this one out. So it passes through the point. And once again, I'm just going to use the slope-intercept form, since that seems to be what most of the students want to use. So y equals mx plus b. I already said the slope is 1. So y is equal to 1 times the x-coordinate. So wait a second. I should have filled the value in for y. So the y value is a -3 is equal to 1. That's the slope times the x-coordinate plus b. -3 is equal to 2 plus b. Subtract 2 from both sides. Minus 5 is equal to b. So what we see is that we have a slope of 1. We have b is equal to minus 5. So this is the equation that has a slope of 1 and a y-intercept of a -5. So it has to be that one. Last problem. Here is a line that I'm perpendicular to. So the slope of the line I'm perpendicular to is a -3/5. My slope, the slope of my line, is the negative reciprocal. So we take and we change the sign, and we also take the reciprocal, so that would be 5/3. So I'm looking for one of these that has 5/3 as a slope. That would be C. I don't need to carry on any further because there's only one of those has the right slope. So that would be the answer. And I think we've covered everything. That's it.